Hello and welcome back to the Google APIs for Rust and YouTube Uploader development stream. It's Byron speaking. And we're still dealing with, well, not the Lexer anymore, because the JSON Lexer is now feature complete and quite fast, if I may say so. At least it's a good basis for what we are going to do, because we need every inch of performance. I'm just saying that. We don't actually need every inch of performance. We are much faster than we need to be. But I like to have maintainable and fast code, and it kind of goes hand in hand when you write Rust. So now that the Lexer is complete, I would like to have my first filter. I want to have a filter that is able to strip null values off, basically out of a stream of tokens. And this is what we do. So these filters, they always they always work on token streams, which are yielded by an aggregated iterator over tokens. And as we know, the Lexer happens to be an iterator over tokens. It takes an iterator of characters and spits out during iteration tokens that are parsed from the iterator. That's pretty awesome. So it's like a little pipeline thingy that we are building here. Thanks to iterators, it's easy to combine. So they're all aggregating each other, so to say. And what we want is we want to aggregate a Lexer here, which we do, because that will yield the tokens that we need to consume in order to spit out new tokens that will not contain null values. So we are basically a scanner, and we're scanning a stream of things. We don't have a huge buffer, basically. We only have the smallest buffer needed to do our job. And how much would that be? So let's think hard here. Let's try to use our brain. In the morning, this is still kind of possible. We have a chance to do this. So how would that be? So my first naive thought is that, we need a persistent, like in-belly buffer. I call this belly always. We need an in-belly buffer of at least 2 tokens, because we take off 1 token, which is always on the stack, and once we have that, we can know that we actually have a full match or not. The thing is, if the third token is not what we expect to see, and we will see a lot of, oh, we have a string Colin. Oh no, it's not a null, it's a value. We have that a lot. Then we basically have to allow the then we basically what we're doing is we are peaking. Yeah, that's what we do. Yeah. It's kind of, I would like to keep the paradigm straight. We are peaking in a way. Yeah, how is this supposed to be implemented? Because the other one, the Lexer, he now has putback, but he actually doesn't like it. He was perfectly fine without putback until numbers came along. Number parsing came along. Maybe I want to do it like that. Yeah. See? Major change. But this guy can't do without. It needs some sort of buffer, and I wonder how I want to implement that. And we need a buffer of a specific size. It's statically known, and I would like it to be statically known, but it's also a particular size of 2, I guess. Maybe 3, but probably not. The thing is, we also have to take out the comma if there is one. So that's kind of this peak functionality that we might want to have. So we know that there is a peak iterator that is generic, which allows us to peak 1 item ahead. And this is something we could do. So let's just play through how we could implement this, because I actually don't know. Should we have a put back mentality? Sure. I mean, the problem is if we have cached something basically in our belly, like if we have, because if we encounter a string, we have to keep it depending on our current state. But if we are in a clean state, basically, we are a state machine after all, all these iterators are in a way, we have to keep it. Then if there's a colon, we have to keep it. We can't return it because we want to possibly filter it out, right? We want to drop them. And then the next value, if it's not what we expect it to be, we know that these two that we kept, we have to return them during the next calls. So we basically have to first deplete our buffer before we can keep going. And this depletion mechanism, I would love to kind of keep out of my site. But I won't be able to do it because it all has to be implemented here. Yeah, so I guess the state is kind of super important. So what's the state? We are free. We are kind of open to find new needs string, like needs first string. Right? This is the state that we are in most of the time. We are just going through and we need a first string, and if we don't find it, we just return it right away without buffering. I think I should just start implementing this because it starts making sense. But we will learn from our previous lessons and say, well, we really like to have an enum for our state, which is representing our parse mode, right? So one string. So one string is the mode we start off in. We are free roaming and are looking for the first token that is a string. Okay. So also we will obviously iterate. Yeah, for now I just implemented like brutally. The cool thing is we can just take the next item here directly. Self, because we are never taking more than one item off, do we? And that's the question. I think I would like to have some sort of look ahead here. Because if we have a string, then I will just look ahead and try to find all the items that I need and put them back. And I put back at most 3, right? Yeah, and then I deplete the buffer. So let's have this. Let's have a buff of 3 tokens. There's something I need. And I will also have a buffer index that says what's the next buffer item is that I want to write. That way I don't have to make 3 of these optional. Yeah, I can just initial. The thing is, do I want them to be optional? I would still have to keep a buffer index to know. No, I wouldn't have to keep a buffer index. But also, the thing is, I don't want to, these tokens, I also don't want to initialize them. They should all be none initially, kind of. Is this what I want? Otherwise, I have to make up a default token that makes no sense, which could... Yeah, which wouldn't be idiomatic, so let's make it an optional token then. And then we have a buffer index, bi, usize, which points to the current index here. Filter new will now need to be adjusted. The thing is, the buffers, I'm kind of having the tendency to have an optional buffer. Which might be more what I need than I just default the tokens, which currently do not have a default. I could just pick one. I could just auto-implement default as well. That's not a big deal. Well, But then again, it's kind of, the optional stuff is just more memory used, more memory to be read and written, and more stuff to be unpacked then for no real reason. Because now I have to initialize this thing, but I come on, I initialize it with none. Done. None. There you go. And we have nothing in there. So the next item is null. And if this is 3, then we know we are full, right? That's how we do it. So that's that. Buffer index is null. Cool. So there we go. So I think the point is, if that buffer index is greater than 0, then we have something that we want to take out. So we have a result, which is self buffer index, and we take it like literally, and it's exactly what we need, an optional something. And we actually expect it to be not none, right? We can debug assert this. Res is some. Because this is why, now this optional thing is just for the initialization part, so that we don't have to make it up a default. This is really the only reason. And it's still idiomatic and stuff, and let the optimizer do its thing, I say. So yeah, now we can decrement our index by 1 and return res, and we are done. So that's our deplete buffer mode. This is what happens once we have peeked ahead, right? This is what we do all the time now. The cool thing is, I think I like the option stuff, because we are naturally storing options. We can just hit next, and kind of keep options in there, and it is a total possibility that the optional is none, because we could hit the end while scanning, and this would be an invalid sequence then, because we always have triplets of key colon value, but we don't know that. And the cool thing about this is that the I don't know if there is a next token is totally represented by the option, and we kind of keep through with that. So our code is forced to deal with that correctly, so we can't be killed by something that would resemble an invalid token stream, which could be manufactured to give us some buffer overflows, which we obviously don't have because we are Rust, but still, you see what I mean. Anyway, so we take it out. And I like I also like the idea of taking stuff out of something, because this further signals that now this thing has been consumed. It's not in there anymore, and you can't obviously use it. If you try, you will get a panic and you will abort right away, which really shows that you have a problem. You have a problem, sir. I know that. So here we go, the state. And the state is something we have to actually, we don't. Right now, I don't think we need a state. No, because we are not working like the Lexer does. See, don't throw the hammer at everything just because the hammer happens to be a great tool to put in nails. Not everything is a nail, right? It's funny how you as a human being are trapped in kind of thinking patterns, and at some point, to a hammer, everything is a nail, right? But it's not. And the cool thing about the human brain is that it's a hammer and a saw and a gun, whatever you need to solve that problem. And I actually don't like the gun analogy, because that's kind of not so very peaceful. Good. So there's no matching here. So here we go. So the next token is self. Where's the self source? Next. So that's our token, and we want to match on it, I guess. Even though, yeah, I will do it the same. We keep it, then we match on it, and if it's something we want, we keep matching until we we get out. And we put tokens back once we realize that it's not for us. So match on the token. So if it is some, and in there we have a oh no, it gets interesting. First time I actually have to match on a item. So I want to get kind, and I'm not interested in this. If kind is token type, I'll have to get this. As token type string. There we go. So that's the positive match, and here we can do stuff. In any other case, just return token. And the question is, should I make this a returning match? We put back stuff, we return one token, put back others. So I think in any case we will return a token here. So we can make this idiomatic. That's a big match now, a big nested match, but it doesn't go too deep, I think. Just 3 levels or so, 4. That's still acceptable. 3, 2, 4, 5, 6, 7, 8, 9. Yeah, can do, I guess. If I can flatten it, I would love to flatten it. But on the other hand, the matching kind of forces me to deal with all the cases, I guess. And that's what I want. Okay, does that work? Let's return none here just for the fun. Oh yeah, yeah, this is the case here. Let's see if that compiles. Filters. Sorry, iterator. Unresolved name by. Did you mean self by? I did. It's cool that the syntax highlighting then is where it actually is. That's awesome. I really like this linter. It's a new way. So here we have another one. This pattern has 2 fields, but the corresponding variant has 1 field. Oh yeah, because we have a token, and then I think the struct matching stuff goes like this, maybe? I don't know, probably not. Expected ident. Yeah, it's just syntax that I'm not getting right here. I want to match on a struct, and I know I can. Okay, let's look it up. I know there was something in the book somewhere. Is that a book here? Yeah. Do you show me how? Okay, how would match show me how to match on structs if structs come afterwards? So I guess, or maybe it's patterns. Ranges, bindings, guards. Is this new? I know this guard stuff here. Value ... got an int. Oh, that's interesting. The ... I guess I have to use... No, I don't. I actually don't know. But the ... is interesting. I never used this. And probably you need that because I still can't match on integers correctly. Here, look at that. He says map x to x, right? So this is the struct name, and then I can assign it to a variable. And this means ignore the rest. Okay, dude, then will you map kind to kind and ignore the rest? Hey, what's up? Cannot bind by move into a pattern guard. True. I don't want that. I don't want you. Oh man, what's now? The trait token type is not implemented. Partial comparison. Really? partial equality. I thought I had it. It is. Excuse me? Oh yeah, it's a ref. Now we're talking. Cool, and it's unused. Well, what's now? Where's the warning again? This pattern is redundant and can be removed. The kind in this pattern. Oh, really? Thank you. Ah, they optimized it. Yeah, that's cool. So this, in fact, what the book shows, like YYXX, hey, it's redundant. Yeah, obviously it's redundant, right? But previously it had to be done like that. Now it doesn't need to be done like that anymore. Awesome. That's very nice. I like it. It just got better. Cool. So that's our struct match. That's really, really nice. So we first search for a string. That's what that says, right? And that's pretty cool because this way we keep it on the same level. And right now I just return none just to see if it works, and it does work. Okay, so we have found something that makes sense for us. And if it doesn't, we return it. Cool. This means we want to store it. We just want to stash it away. Let's have a function that does that for us so that the BI stuff, you know, put and take. Put token, take token. I want to have this automated. And then put, and we only put tokens, so we just keep it simple. Mod self. Yeah, I think we take ownership. Once you put it away, we put it away. Then we don't use it anymore. So have it. T token. Is it an optional? Yes, it's going to be an optional. And we won't have a debug assert because we have an index check already. So what we do is a blunt self buff self bi is token and self bi plus equals 1. And the cool thing is we can optimize this code, which then looks better. Fn take mod self, same thing but inverse, returns an optional token. Yeah, I keep the options alive because we need to return them anyway. Otherwise I would have normal tokens, but we had that already. Just reason to myself. So let res be self buff self bi take. So now it's gone from there. Decrement self bi minus equal 1 and return res. Both are unused. So now we just say self take. There we go. I like this linter. And this is not needed anymore. The debug assert, yeah, let's do it. Maybe we shouldn't do it. Maybe we can have more stupid code that way. Maybe we can have more stupid. Let's not do it for now. I like stupid code. Or code that is just as smart as it needs to be. That's more the phrasing I'd like to use here. So, cool thing is, now we know that this guy is right, so we put it. And we don't want to look at it anymore. We don't care. We know it's the right thing. Then we get the next one and match on it, right? And we want it to be a colon. So self source next is a some token ref kind, rest doesn't matter, if kind is token type colon. Okay. Oh, wait. I'm missing these here. And that's the opening brace. The default case, you know, okay, now we have a mismatch. This doesn't work. In the default case, we took it and we put, you know, we just put it. Oh man, now we would have to take the first one. It's more like a, we want to have something more like a pop thing. I think take wants to take from the front. Yes, I think that's the only problem here. So it's 3 const buff size being a use size 3. So now I can dump this here. I can use it here because we take from the front, which also means we put to the back, right? Does it even matter? It's all about the buffer index. I don't think it matters. The question I have is, do I have to do any kind of computation? Yes, we want to. I mean, what is this? Let's think about what we have learned over the years. It's a first in, first out. And our buffer kind of keeps track of the end of the thing. And we know that basically we can basically compute from there where... No, actually, we always... The thing is, we would have to... If we pop front, which is what this is... Yeah, shit, we have to pop... Can't just take, we have to pop front. And pop front is a shitty operation for us. Unless we have a cursor... How can we implement this efficiently? We would need 2 cursors? Yeah, I think we just have to put it... We put stuff in. It doesn't matter where we put it, really. It's just important that... Okay, so now we have... Let's just see what we have here. Damn it, I'm dumb when it comes to that. Probably I'm dumb in general, but I realize it at least when I have to do this kind of stuff. So we put in something at 0, and our buffer index is now 1. Here, that's the guy. And I would like to take out the 0. So what can I do? I can... And also what happens if I have taken out the 0. So I need 2 cursors to keep track of that, or I have to basically copy the entire contents of what comes after over one to the left, which is something I prefer not to do because that's an expensive operation. I could have a... Yeah, so BLI... buffer last index, BLF buffer first index. And when I push stuff, you know, we are a very special purpose thing. And I just want to remember where things are and keep track of the indices. Yeah, I think that's how I want to do it. So, getting more complicated, no likey, but I think I have to do it. Maybe refactoring later today will teach me otherwise. Maybe what I'm doing here is a ring buffer. Let's see what a ring buffer can do. There must be a standard pattern. Ring. Do you have a ring here? Maybe I should use a vector for this. But a vector implements pop front in an inefficient way, I guess. What collections do we have? Show me. Must be standard. Vecdeck maybe. Vecdeck. A deck can be popped. Vecdeck. You want a vec that supports efficient insertion at both ends of the sequence. You want a double-ended queue deck. This is what I want. Cool. That's what I want. What's a vecdeck like? Because I think I would implement a vecdeck now, and I'd rather not, so I just initialize the vecdeck or give the vecdeck a capacity of 3 tokens, and then I'm good. Yeah. And this is what this is really good here. You know, use this, if, that, and so on. And I need a deck, a vecdeck. Show me where's the vecdeck? Here is a vecdeck. Growable ring buffer C. How is it implemented? It's not a linked list or anything, so I think show me your internals. Tail, head, capacity. It's heap allocated, but it's okay. So the only thing that is worse about this is that it's heap allocated, but the overall cost for the allocation that is required once is low, because we don't create thousands of our filters. We just set up a filter chain once, and then they do a lot of work. So yes, I will use a vecdeck, and we'll be done with that. Use std collections vecdeck. Excuse me, vecdeck. I was like, vecdeck? No, that looked different. And that also looks different usually if you can spell. So there's a vecdeck, and my buff is now a gorgeous vecdeck of optionals. Vecdeck of these guys. There we go. One size fits all? Nope, it doesn't. Cool. So I can say, yeah, so I don't need to do that. I can just use the deck directly, right? What can you do, vecdeck? I would like to put that down, but I can't because it's not yet fixed. Thank you. Probably it's not going to be fixed until release, but I will deal with that. So pop front, push back and pop front. Huh? That's what we do. Yeah, that's what we do. Cool. Less code. I love it. So if self, oh yeah, and the initialization here has to change a lot. Vecdeck with capacity 3. Thank you. Yeah, so there's some overhead as well associated with that, because push front has to check sizes and stuff. So we could implement it more efficiently. That's what I'm saying. We could. And also it's relatively easy to do that. So that could make me rethink it, but I think we want to do this as part of the optimization. Right now, let's get the code to work. And the easiest way is to use preset types that are general and thus a bit slower, but still they work. And that's one less thing to worry about for now. And then we might, let's see how much we get. Why not implement a little ring buffer that is super custom to us? Why not? It's a performance thing, right? So self buff lang greater than 0. And then we say pop front. And yeah, actually return this. We don't need that anymore. Self buff push back token. Okay, so we push it to the back, push front. That's a FIFO. First in, first out, efficient ring buffer style stuff. So we get the next token. If it's a Cullen, we say, wow, that's great. Push it back. Self buff push back. Ah, we wanna keep it. We always keep our tokens. And that's just a ref here, right? Can we push it back in this under these circumstances? Let's return none here just to test that. And here, if it's not what we want, wait, I think we always push it back, huh? We match on it and we always push it back. Because we have to return the stuff in order. It's just a question of whether or not we continue drilling down or not. So here we take it. Here we push it back. What do we do here? No, wait. So here we definitely have to... Yeah, the thing is I want to push it back because we are one level deep already. I just don't want to lose it. Right now we give up ownership. I also don't want to take it out again. I can probably get a reference to the last thing. Append, resize. I can probably get an index. I can just index that stuff. That would probably be the way you do it. But I thought maybe backmat. Ah, that's the way you do it. Back and front. Yeah, that's how you want to access these after putting them. So I guess in any case, we put them. And this moment we can also do it like that. And then we can, yeah, so we know it's a string, we know we want it. And the next we take, and then we have a look at it. Self buff back, which is an optional. I will unwrap it right away because I know I just push stuff onto it. And deref it. And now I have, actually I can well, you know, I don't have to. Let's keep it all, because that costs you, the unwrap costs you another check. And this kind of natively costs you anyway. And since we have to do it, let's do it right. So, if that is a token, and I guess this will then be more like this, it's a reference to a token, yeah? And it's Cullen, and we pushed it back already, then we can drill down. If it's not a Cullen, then we will pop front. This is what we return then. So we will then have one thing on the buffer, and that's it. But that's how that goes. Yeah, that's how that goes. Self buff pop front. Here you go. And that's the return of that. So now everything returns. This should compile. It doesn't, because that pop front generally is something he doesn't like so much. It's not implementing with the self pop front, self buff pop front. Okay, so what's the next? Expected option of token, found option of token. Whoa. Okay, so we basically wanna change this, I guess, because we know that we have something there. Now we would have a double. Oh man. Now we have to have multiple matches there. or I deal with it. I like the idea of just being able to use these guys, but on the other hand, maybe I should unwrap them. Maybe I should not. Maybe I should keep them as they are. Okay, that's an... I could unwrap them here, sure. Do I want to unwrap? Or do I want to keep them as they are? Of course, the thing is, I know that something is in here that we can pop. So I guess this doesn't cut it anymore. This is not what we want. This also means I can't just push back the token. I have to unwrap it. And this is kind of that's kind of duplicating the work. Because I now want to take out the token. So I have a double match here. So we have some token. And then I can match on the token's kind like this, but it looks different, obviously. Yeah, so let's rephrase that. Kind of. Somehow. So we have some and none. I think this will lead to better code after all. So now we have to, oops. Yeah, if we have, yeah, but it's also more nested now. So if we have none, return none now, obviously. If we have some token, we can use it. We match on the token. Yeah, let's take this off for now, just to get the stuff right. So we match on the token, we match on the token kind, because that's the only thing we are interested in. We match on the token kind and say, well, if it is a string, then we are happy about ourselves. And I wonder if we can then consume the token, because we have a binding to it here. Probably not, but maybe yes, because it's copyable. I would also clone it if necessary. I mean, come on. Who cares about such an enum? I don't. So match on the token kind. If it's a string, we are very, very happy. Push it and keep going. This is maybe also something I want to take off for now. If it's anything else, we've lost the game, and we will return the token as is. So we are consuming the hell out of the token while we have a match on it, which might just not work. But it's okay. Why am I so far to the right? So that's the match on the token kind. Okay. But that's that. So that could... Let's return none here. That could compile. If it has a chance to compile, that is. Like this. Does it work? It does work. That's very nice. Maybe I just don't copy back the stuff I had and start fresh, because the logic wasn't anything I wanted to have here. The thing is, we have to do this kind of double match all the time now. First unroll it, and all we do... Oh wait, this shouldn't work, huh? And the buff size we do indeed not use anymore. Yeah, Lexer. Oh no, wait, the filter, huh? But it did compile. Oh, I should rename it to filter. Cool, that does compile. Okay, let's keep drilling down. Let's see where we end up. Oops. It's the first version anyway. So now we have a string. Now the next one is supposed to be a colon. From now on we have to store everything because we have to return that stuff in order. And there's no way out anymore. Here we have an early bailout and we don't have to go over our ring buffer, but now we have to do that. So self buff push back, self source read. Oh, we can't do it. We have to match on the next thing, which is also not read but next, and say, okay, it's some token. That's very nice. Or it's none. So if it's none, we can actually pop our front. That's cool. Self buff pop front, which clears our buffer and bails out as early as possible, which is, I think, the cool thing here. Because, you know, we are totally impenetrable when it comes to invalid streams or something. And we are forced to do it right. I have kind of no other way. It's just awesome. I like it. And it's also efficient because we don't use unwrap ever just because we know it's in there. No, we use match all the time, which is the way you want to do this, to not duplicate instructions, to basically peek into an enum. Okay, so we have a token. So now we have to see if it is what we need. We want a colon, right? So we match on self buff back, the stuff we just had. And I will now just unroll. Oh no, wait, sorry. We didn't push. We just pushed the string here. And now we push the colon. Let's call it like that. str token. str token. str token. Because it's a string token. And otherwise I get very confused. Oh no, here we don't know yet what it is. That's why. But let's just say that's our hope. But then also it's kind of wrong, is it? It's kind of, I don't know. It's always a token until we know it's a string. Have to do it like that. So that match is going to be evil. So remember our string token, which is, you know, as good as it gets here, I guess. Then we match on the next. See if it's some. If it's some, I think the point is that we now have to push it back. There's no way around it. Because we already pushed back something else. So we have a token and we need to keep track of it no matter what. If it's right or wrong, who cares? So we push it back and then we match on it. We know it's something and we took it out of there. This back will return an option of a reference to a token. And we're only interested in the kind because that will tell us if we can go on or not. So that's a borrow to a token structure whose kind we are very interested in. And nothing else. Basically. Okay, now it looks different, huh? Because now we basically show we are not interested in most of the stuff that's in there. We just want to know, we want to peek. Is it the kind that we want? If kind is token type colon, oh my god, it's going to be a line break hell. And no way around it. I think I will turn off line breaks for this. Nice. And if it's none, sorry, if this matches, and if it doesn't match, now we are exhaustive. we once again say, well, then pop front, and we keep going, right? Then we deplete our buffer and keep searching. And that's a cool way to implement it because, oh no, wait. Yeah, it's an invalid, if it's not a colon, it's an invalid stream anyway, and we can't make any assumptions. So yeah, that's what we do. But we will definitely filter our triplets of these things. This is what we are made to do. Self, buff, pop front, and there you go. Cool. So here we have something that we want, and once again, we match on the next thing, which should be a string. Word wrap. Match self source next. So if we have none, we once again bail out. I'm not liking this super deep matching at all, maintenance wise. But I ask, I would want to bail out early, but we can't bail out unless we use ifs. And I think ifs, then you can say if not is, or if is none, then bail out. The problem is with that, then we will basically unpack the structure like two times more than we need to, or 3 times more than we need to, which is hindering performance. So with matches, we can't do the early bailout style at all. We have to nest. And with that kind of stuff is what you get. Sorry. And it goes to the right as far as it goes. That's what word wrap disabling is there for. But with word wrap on, you can't do this. Okay, so here we have none, and we say, yeah, well then break abort. If you have some token, we take it. We take ownership. Let's try to get the syntax right. And the cool thing is, at least we are not doing the return all the time, because we know we will always return something in any branch. So if it's some, now we have to check the type again. So, but we also have to remember it, which is the most important thing. Push back token. Now we can check the type. Match self buff back. If it is some token to a kind, and that's it. If kind is token type string, then we are good. But we have one more level. We have to peek to see if there is a comma. If there's a comma, we take that as well. Otherwise, we don't. Otherwise, we bail out. So we are not yet done, which is terrible. Yeah, that's the one. Then here, boom. If this is something else, no match, you know the drill. Pop front. And you're out of there. The cool thing is that the type of the pop front now natively matches, and it's kind of more efficient to store, and that's what we have to do. It's interesting how if you do it the right way, or how doing it the I think objectively right way forces you into more efficient data structures and basically greater efficiency in general. I mean, this is something I don't like, but it kind of happens, and I understand why it happens. And this thing is probably as fast as a triple value pattern matcher goes. And this is also why machines have been invented can be built automatically by a grammar. They have more call overhead, obviously, because they're not static, but runtime. But at least you don't have to type this out. Like just imagine if I have a pattern that has like 10 of these things, you go crazy. But it might be worth the optimization effort under circumstances. All right, so now we know it's a string. That's awesome, which also means that we can now think about forgetting stuff. We have a string, colon, string, triplet, and could forget it if there is no comma following. So the thing is, I think what we want to do, yeah. So we already forget it. That's what we forget. And we forget it. So we clear our buffer. Buff clear. Boom, go away. We will never return you. And now we peek to see if it's a comma. If it is a comma, we forget it as well. And now we could also try to be more efficient and just use an unwrap style. Let's get, yeah, but I guess we don't know. Match self source. So we get the next token here. If it's some token, we're cool. If it's none, then we are depleted and we are returning none. And we will keep doing so, and that's where this ends. But if it's some, then we want to see if it's a, and we don't even store it, because we either, oh, actually we do store it. We have to store it now. No, wait, we don't have to store it now, because if it's not, we just forgot everything. So that's kind of the logical next thing that we would return anyway. So if it's not, oh, wait. What if it's a string again? Then we would have to be recursive, kind of. But if we put it into our buffer, then we will not use it the way we want to use it. So that could be a problem. If it's a, I mean, we could enter recursion, but depending, then you can manufacture a stream of tokens that will actually break us. Because you can manufacture a totally invalid JSON stream that causes us to, it would give us string, colon, string, string, colon, string, string, colon, string, and each string, colon, string pair causes a recursion level. And this will then eventually kill our program. I think Stack Overflow is well caught, basically, but you don't want to have such a vulnerability anywhere, because they can then crash your system and take you offline or something. So we don't want that. I just say the normal course of things is that there is either a comma or anything else but a string. And let's just say we require this kind of we acquire this kind of reasonable JSON string. So that's it. And I will put it there, what I just said. I will write it there so that I knew back in the days, or what I meant with that. Good, so now let's match on the type again. And we don't return that token, that's important. Match token kind, now we can do it directly. Token type, if it's a colon, we forget it and return the next one. So that's the cool part here. Token type is a comma. That's cool. Because now we just skip this, we just don't do anything, but return then whatever would be next. And we are done. If it's anything else, return the token. Because then that's the logical next thing. And we assume that this token will not be anything that we could possibly want to filter out. I think I've got a problem. I think I've got a problem. Because now that I've filtered this thing, this is kind of okay, This is okay to do, I think. So what could it be? It could be a brace. Could be... Yeah, most of the time I think it will be a brace. If it is a comma, I forget it. But the problem is that if I read next and return it, I will not... Then this is very likely to be another key. And this key is something I would very much like to see the actual next time I read next. And also I would love to not get into recursion just because everything is null. You know, I could recurse here. I could just call myself. This is what I might have to do, but this is a vulnerability. And also we don't... Yeah, I mean, I've got an empty buffer here, so I can actually do it. But this means for every consecutive item, yeah. So I would need, this problem can only be circumvented if I have now I need a stack. I need a stack that can dynamically grow. So I need a vector of tokens. And the next token is either source next or the last thing I put onto this vector. That's what I need to do. And source... And this only happens once, right? It's only at the connection points. So I actually just need a buffer like next token or something. This is like our peak here. No, wait. Whoa. No, I need to get into recursion. Because I can't return anything here because I don't know what the heck is going on. So recursion is the simple solution for this. But we can always resolve recursion by having a loop. And I guess we want to put a loop. Oh my God. So let's state what we have to state here. The thing is, if we want to put a loop around it, you know, at this point here, I actually want to, in any case, put this onto my looping buffer because I have to treat the next... I either forget the next token, which if it's a comma, but this token here, this has to be on our buffer next token. Yeah, I think all we need is a next token, huh? Can we have it on the stack? Which would mean that we always start off with a fresh one and then we dial down. So it's kind of a chain of events. So I say next. So it's an optional token, obviously. And if what happens... what happens if there is no optional token anymore? I mean, what's the end condition of this? Because we would need to have a loop for this. Jesus Christ, it's my first time I have implemented such a filter. We just have a pattern of a simple triplet with an optional fourth one. Yeah, so this needs to be my next token. For all I know, this is the next token I have to work on. Let's call it next token, I guess. Because we unpack token and I want to have this local variable token just to be always the unpacked usable token kind of. Okay, so I will just see if this compiles before I change it into a loop, because it's enough, isn't it? And it also doesn't like it, and it's definitely enough. It's a syntax error. Expected identifier from keyboard match. 37. Yeah, well, it's here. We see it. There we go. Self is probably bound somewhere, huh? Oh, self buff. I love this linter. It really changes the way you work. Speeds it up. So now just token that it doesn't like. What's the deal? That's definitely exhaustive and return something, but yeah, I could probably read that, huh? I didn't even read it. Mismatch types. Oh yeah, it's a unpacked token. For now we just want to see that this compiles. Oh. Oh, buff back there. We got buff back. We are in a buff back situation here. Oh shit. Haha, thank you, Rust. I was constantly referring to a reference to the back while trying to push to it, which obviously is a bad idea. I can clone it. Yeah, the thing is that is actually safe in our case. It wouldn't crash, I think. But it's also not, I understand why he says that. I do totally understand that. I could clone it. Right now I don't think it's clonable, but, well, maybe it is. It is clonable. So I could do just that. I think I will have to. Is there another way? I think it's the problem with the pushback stuff. I think there is another way. You could rewrite this. You could say, well, now we know it's a string token. And in the moment we bail out, we could push what we have to push. Let's do it like that. And we keep the stuff alive in their own local variables as long as possible. And when we realize we have to bail out, we return the first one without pushing the vector, which is even better. Okay, let's do this. So here we don't know if here's just a nameless token. And we don't push it back yet. So then I have to watch carefully. So what are we Yeah, so which case is this? That's the question here. Sublime text, where are we? We are here. So this is a colon. This is the have token string. We don't know. But that's the kind of thing we want to figure out. What's this? Oh, actually, that's totally wrong. What I said here. This is a have token and could be a colon. Have token colon? Okay, here we already know that we have a string. What's this? Oh, that's next token. Yeah. No, I thought I could. Interesting. Doesn't want to match here. But up there. Interesting. I see where it ends, but it doesn't want to go up there. Too much stuff going on for Sublime Text. So that's and is a string token. And here we have token kind string. Jesus Christ. And have token. Yeah. Okay, I have to, before I can even see if this is working so far, which it wouldn't. For our case, I think it would. No, it wouldn't work because, well, it would work here. In our case, it should already work. That's the point. But not for all of them, and we will add more cases to really verify this. I don't want to say terrible code, but it's very interesting code to say the least. Better be fast, man. Okay, but it forces you to kind of do your stuff correctly. That's all right. All right, so let's stare at the code one more time and say, yeah, we get a next token. We have a string here. And this pushback stuff we have to delay. That's the point. Interestingly, this one we can push back without issues. We are not asking for that again. Yeah, because that's the first one. Yeah. But I think we are not going to do this anymore. No. So let's kill the pushbacks. I will just hide it for now. Instead, I will move it into string token because now we know what it is. First string token. That is that. Then we take the next, unpack it. And it could be a Cullen token. Right. Cullen candidate. Let's call it like that. Optimizer will do what it has to do. Let Cullen candidate be the token. Thanks. Oh no, wait. No. No, let's do this first. So if we have some, if we have none, now we didn't push anything, so we can just return the sum. We unpacked it at least. First string token. Why? Is this correct? No, it's not correct. Because we know it's a string and we already took the next. Well, it's really about we took the next and oh no, wait, that's correct. We took the next, but there is nothing. So all we have is the first token. Yes, so we circumvent the buffer altogether, which is better. Nice. So that is correct. So now we are here. And we have something which could be a Cullen, which is our Cullen candidate. and we match the Cullen candidate. And now we have two guys. We have first string token and we have another token which is the Cullen candidate. So if we do not have, if this doesn't match our required, and we can match on the type now. Kind can now match directly. If kind is token type Cullen, which is better. Otherwise, we will, and now the push action comes. We just have to push on the Cullen self buff push back Cullen candidate and return our first string token, which is always what we return here, always, and it's always sum. And the candidate is, yeah, we just have pure ones. We don't have, we don't put them anywhere. Good, that's great. So now we get a next token. And at this stage, we have two tokens in limbo, basically. So if we do not get a next, is this missing? Oh, wait. We get a next token. I was on the wrong line here. And we have none. Here we are. Then we just ignore the fact that there is none. We will return some first string token. What's the time saying? I lose track of time. 1:16. But hey, I want to get this to work and compile at least. So return some first string token and push the Cullen candidate. Same thing. Push back Cullen candidate. There we go. Kind of like this. Cool. And if we have some token, then this shall be our second string candidate. And this seems like sound, so let's make it second string candidate is our token. We move it in there. Cool thing is we can't accidentally use token. I love it. And we have a nice name for what we want to do here, because now we know what this is. It's a candidate, nothing more, nothing less. And then we don't do that anymore, but instead, second string candidate match directly on the type, which will bring us down to this. So if it's not a string, but something else, I guess, we will push back in the right order. First, the Cullen candidate, then the second string candidate, and you kind of see the pattern that pop front still happens here. Okay, good. Because I was thinking, hey, maybe I can get around that. I don't need it anymore. That would be nice. And I do wonder if this thing is efficient. So if I mean, after all, I cleared after a while, so I think this should be fine. This should be efficient. So, and now at the end, I, as usual, return the first guy. First string token. And I wonder, yeah, so this is, it's not a string, so it's something else. Could easily be the case. It could be a number, it could be a Boolean or something. So that's kind of a very common case here, that we get very, very far and then have to abort anyway. But if it happens to be a string, then we can forget what we had so far, but fortunately we didn't put anything onto our buffer, right? This just means we will not put it onto the buffer. This works by just not putting it onto the ring buffer. And then we try to peek to see if there is a, well, kind of, let's not call it peek. See if there is a optional comma, which should be there if it's a well-formatted thing, which can be there if it's even not well-formatted, then it will be well-formatted afterwards. That's kind of the kind of way JSONs work, right? So here we have a, so what if we do not have a token? This means we just forget everything and we are done because there's nothing coming next. If we have a token, then this is a comma candidate. We just keep going with the style here, which is the token. You know what? I could make this comma candidate right away. Like this. Pardon. I could also make this string candidate right away. First string token. This is first string candidate. Let me match on the type. Where do you use this token? If it's not the case, then I return the first string candidate. Here we go. If it is, then we know first string. Then we know that this is the case. And we assign it and may never use that again. Good. And now we get to the interesting point where we have been last time. So basically, comma candidate, wait, that's now this. So that saved us a few lines here. So now we check on the comma candidate, and we are where we have been before, at the point where we think it could work. For at least our simple case here, it could totally work. And that would be a good end of this session, even though we will have to loop over this because we will kind of lose our chance to check on the next one. So we will have to keep going. Okay, there's still, oh yeah, that's comma candidate now. It actually built. Assertion failed. Left is 13, so it found nothing. But I think it's okay, since we will have to take a little break here anyway. And if not for the sake of sanity of the dear audience, for the sake of my own sanity. So let's commit here and be done with it. Yeah. Null filter. Let's not do it like that. Initial implementation. It is known to not work in all cases. For instance, it can only take one. That's one key value pair at a time, no consecutive, like this, no consecutive ones. But besides that, is a pretty optimal implementation, even though it ain't a pretty one. However, the test still fails. We match nothing for some reason. Must be evaluated later. All right, but that is it. Good first start. Very interesting to implement this. Thanks for watching and have a good day.